Tell me about a time communication helped prevent a problem. Introduction. This is a common behavioral interview question for software developers, backend developers, full-stack developers, senior developers, and team leads. Interviewers ask this question to understand whether you communicate proactively, how you identify and raise risks early, how you prevent misunderstandings, how you coordinate with developers, QA, and product owners, how you handle dependencies and blockers, how you prevent production defects, how you protect the team from last-minute surprises. This question is especially important for check Java developers, backend developers, Spring Boot developers, full-stack developers, senior software developers, team leads, agile teams, cross-functional teams. The best way to answer this question is by using the STAR method. STAR means S. Situation. Explain the background. T. Task. Explain your responsibility. A. Action. Explain what you personally did. R. Result. Explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section, because interviewers want to understand exactly what you communicated, who you involved, and how the communication prevented a problem. Question: tell me about a time communication helped prevent a problem. Example 1. Clarifying an authorization requirement before development. Situation: in one sprint, our team was building a customer profile update feature. The story listed several editable fields, but it did not clearly specify that one sensitive field could be updated only by administrators. The front-end developer assumed all logged-in users could update it, while I believed it should be restricted. Task: I was responsible for implementing the backend API, and I needed to clarify the requirement before the team built inconsistent behavior. Action: instead of making an assumption, I raised the question during backlog refinement. I asked the product owner which users should be able to update the field, whether normal users should only view it, whether the action required audit logging, what response should be returned to unauthorized users, whether the front-end should hide the field. I also involved QA and the front-end developer, so everyone heard the same decision. The product owner confirmed that only administrators should be able to update the field. We updated the acceptance criteria and documented the role-based behavior. I implemented check backend authorization, service layer permission check forbidden response for normal users, check audit logging, tests for admin and non-admin access. The front-end developer also updated the screen so normal users could not edit the field. Result: the communication prevented a security issue where normal users might have been able to update restricted information. It also prevented front-end and back-end behavior from becoming inconsistent. QA had clear authorization scenarios, and the feature was delivered correctly. Why this answer works? This answer is strong because it shows C. Proactive requirement clarification. C. Security awareness. C. Product owner collaboration. C. Front-end and back-end alignment. C. QA involvement. C. Prevention of a production defect. Example 2. Raising an integration blocker, early situation. In one project, our Spring Boot service depended on an API owned by another internal team. During the sprint, I discovered that the downstream endpoint was not available in the QA environment. If the issue remained unnoticed, QA would not be able to complete end-to-end testing before release. Task: I needed to communicate the dependency problem early and help the teams prepare a mitigation plan. Action: I first confirmed the environment status with the downstream team. Then I raised the blocker during daily stand-up and documented it in the story. I explained which feature was affected, what development could continue, what testing was blocked, when QA needed the endpoint, how the sprint goal could be affected. I contacted the downstream team and arranged a short discussion. Together, we confirmed. Correct. Expected endpoint availability. Check. API request and response contract. Check. Required security headers. Check. Test data. Check. Known limitations. Error responses. While waiting for the real endpoint, I created mock responses so our development and unit testing could continue. QA also began preparing test cases using the confirmed contract. Result: the dependency did not become a last-minute surprise. The other team prioritized the environment deployment. Once the endpoint became available, our integration and QA testing were completed quickly because the contract and test cases were already prepared. Why this answer works? This answer is good because it shows early blocker communication, cross-team coordination, dependency management, mitigation planning, agile transparency, prevention of release delay. Example 3. Preventing an incorrect report calculation situation. In one project, I was implementing a report that calculated daily transaction totals. The requirement mentioned a date range, but did not specify whether the system should use UTC or the business time zone. The difference could affect transactions created near midnight. Task: I needed to clarify the time zone rule before implementing the calculation. Action: I created sample scenarios to show the difference. For example, I showed a transaction created late in the evening in the business time zone, but recorded as the next day in UTC. I shared the examples with the product owner, business analyst, and QA. I asked, which time zone should define the business day, whether the end date should include the full day, how records near midnight should be handled, how daylight saving time should be handled, whether canceled transactions should be excluded. The business team confirmed that the report must follow the business time zone. We documented the calculation rules and created expected results using sample data. I implemented the date filtering using the confirmed time zone and added tests for click records near midnight, month-end records, daylight saving time changes, inclusive end dates, empty results. Result: the communication prevented incorrect report totals from reaching production. QA used sample scenarios to verify the calculation. The business team had confidence that the report matched its operational definition of a business day. Why this answer works? This answer is strong because it shows check, business rule clarification, time zone awareness, scenario-based communication, QA collaboration, reporting accuracy, prevention of data errors. Example 4. Preventing a risky late deployment situation. In one release, a critical API change was ready late in the afternoon. The team was considering deploying it immediately to meet the planned release date. The change affected database updates and a downstream service integration. Task: I needed to communicate the operational risk and recommend a safer deployment approach. Action: I acknowledged that the code and testing were complete. However, I explained that deploying late would leave limited support coverage if a problem occurred. I clearly described the risk. Check. Fewer team members would be available. Database rollback could require coordination. Downstream failures might not be noticed quickly. Business users could be affected overnight. Monitoring time after deployment would be limited. Instead of simply opposing the deployment, I proposed deploying the next morning. I prepared a safer plan that included CUC, deployment checklist, CUC, database validation steps, CUC, smoke tests, CUC, monitoring dashboard, CUC, rollback instructions, CUC, support contacts, CUC, post-deployment observation period. I shared the plan with the release manager, product owner, QA, and operations team. Result: the stakeholders agreed to move the deployment to the next morning. The release was completed with the full team available. The deployment succeeded, and the team had enough time to monitor the system carefully. Why this answer works? This answer is good because it shows check, production judgment, risk communication, stakeholder coordination, deployment planning, practical alternative, prevention of operational risk. Example 5. Preventing duplicate Kafka processing situation. In one microservices project, our team was implementing a Kafka consumer for customer update events. During a design discussion, I noticed that the requirement did not explain what should happen if Kafka delivered the same event more than once. Task: I needed to communicate the duplicate processing risk before the consumer was completed. Action: I raised the issue during the technical design review. I explained that message delivery systems can occasionally deliver the same event more than once. If the consumer processed duplicates without protection, it could cause K. Duplicate database updates. K. Repeated notifications. K. Incorrect audit entries. K. Duplicate downstream requests. K. Inconsistent business results. I asked the product owner and developers which operations needed to happen only once. Then, I proposed an idempotency approach. The consumer would read a unique event ID, check whether the event had already been processed, skip completed duplicate events, log duplicate detection safely, retry temporary failures, send permanent failures to a dead letter queue. I also worked with QA to define duplicate message test scenarios. Result: the team added idempotency before release. Duplicate events did not create duplicate business actions. The early design discussion prevented a difficult production data problem. Why this answer works? This answer is strong because it shows. And event-driven architecture knowledge, proactive technical communication, Kafka idempotency, QA alignment, data integrity awareness, prevention of duplicate processing. Example 6. Preventing front-end and back-end contract mismatch situation. In one full-stack project, the front-end and back-end teams were developing a new search feature at the same time. The original story described the data generally, but did not define the exact API response fields. Task: I needed to make sure both sides agreed on the contract before completing the implementations. Action: I arranged a short discussion with the front-end developer and QA engineer. We reviewed, quote, request parameters, response field names, field data types, required and optional fields, pagination metadata, empty result behavior, validation error format, unauthorized response format. I created sample request and response JSON. The front-end developer reviewed the sample and identified 2 additional fields needed by the screen. We added those fields to the response DTO before the backend implementation was finalized. We also agreed that an empty search would return an empty list instead of a null value. I documented the final contract using OpenAPI and linked it to the story. Result: the front-end and back-end integrated smoothly. We avoided late field name changes and response format defects. QA also had a clear contract for integration testing. Why this answer works? This answer is good because it shows it. AC, front-end back-end communication, API contract alignment, early collaboration, documentation, testability, prevention of integration problems. Example 7. Preventing a database migration failure situation. In one release, the application required a database schema update and migration of existing records. During release planning, I noticed that the proposed deployment order started the new application before the data migration was complete. Task: I needed to communicate that the deployment order could cause application failures or inconsistent data. Action: I explained the dependency between the application code and the new schema. The new application expected new database columns, migrated status values, updated indexes, required default values. If the application started too early, it could read incomplete data or fail when accessing missing fields. I raised the concern with developers, database administrators, QA, and the release team. Then, I proposed a deployment sequence. Check, take a database backup. Check, apply backward compatible schema changes. Check, run the migration script. Check, validate record counts. Check, deploy the application. Check, run smoke tests. Check, monitor errors and performance. I documented validation queries and rollback steps. We tested the sequence in a lower environment before production. Result: the production migration completed successfully. The application did not encounter schema or data compatibility issues. The communication and rehearsal prevented a high-risk deployment problem. Why this answer works? This answer is strong because it shows: check, database migration awareness, Check. Release communication. Check. Deployment sequencing. Rollback planning. Cross-functional coordination. Prevention of production failure. Example 8. Preventing scope misunderstanding during a sprint situation. In one sprint, the product owner requested additional export and advanced filtering options for a dashboard after development had already started. The team initially interpreted the request as part of the current sprint. However, completing everything would reduce QA time and put the original sprint goal at risk. Task. I needed to communicate the impact and help clarify what was required for the current release. Action. I reviewed the new requests and estimated their impact. The additional work required. New backend parameters. Database query changes. Export generation. Front-end updates. More test data. Regression testing. I discussed the impact with the product owner, Scrum Master, QA, and developers. I explained that the additions were possible, but including all of them in the current sprint would increase delivery and quality risk. I proposed separating the work. The current sprint would deliver dashboard summary, basic filters, role-based visibility, tested backend API. A later sprint would deliver advanced filters, export functionality, detailed drill down. We updated the stories and acceptance criteria so everyone had the same understanding. Result. The communication prevented the team from silently accepting unrealistic scope. The original sprint goal was delivered on time with enough QA coverage. The additional features were planned properly instead of becoming rushed work. Why this answer works? This answer is good because it shows scope communication, product owner alignment, realistic planning, QA protection, agile teamwork, prevention of rushed delivery. Best short answer version. If you need a short interview answer, you can say, in one sprint, our team was building a customer profile update feature. The story listed several editable fields, but it did not clearly explain that one sensitive field should be updated only by administrators. Before implementing the API, I raised the question during refinement and involved the product owner, front-end developer, and QA. I asked who should be allowed to update the field, whether the action required audit logging, and what response normal users should receive. The product owner confirmed that only administrators should have permission. We updated the acceptance criteria, and I implemented backend authorization, service layer permission checks, audit logging, and tests for admin and non-admin users. The front-end developer also restricted the field in the UI. As a result, the communication prevented a security problem and avoided inconsistent behavior between the front-end and back-end. QA also had clear authorization scenarios to test. Common mistakes to avoid. 1. Giving a general communication example. Bad answer. I communicated well with my team, so there were no problems. Better answer.
Describe the exact issue you noticed, what you communicated,
And what problem was prevented. 2. Waiting until the problem happens. Bad answer. After the integration failed, I told the team about the dependency. Better answer. I raised the dependency risk early and created a mitigation plan before testing was affected. 3. Blaming someone for the misunderstanding. Bad answer. The product owner did not write the requirement properly. Better answer. The acceptance criteria did not clearly define the role behavior, so I asked clarifying questions. 4. Communicating a problem without a solution. Bad answer. I told the team the deployment was risky. Better answer.
I explained the risk and proposed a morning deployment with monitoring and rollback steps.
5. No clear outcome. Bad answer. Everyone agreed with me. Better answer. The team clarified the requirement and prevented unauthorized updates from reaching production. Best practices for answering this question. Use the STAR method. Choose a problem that was genuinely prevented. Explain what warning signs you noticed. Communicate early. Include the right people. Use clear and respectful language. Explain the possible impact. Provide a practical solution. Document important decisions and positive result. What interviewers are looking for. Interviewers want to see whether you can communicate proactively, identify risks before they become incidents, clarify assumptions, raise blockers early, collaborate across teams, protect delivery quality, prevent production problems, keep stakeholders informed, propose solutions instead of only raising concerns. For senior roles, they also want to see agree, risk ownership, cross-team influence, stakeholder management, release judgment, architecture awareness, ability to prevent organizational problems, leadership through communication. Strong words to use in your answer. You can use words like identified, clarified, raised early, clarified, aligned, confirmed, documented, coordinated, escalated appropriately, explained the impact, proposed a mitigation, prevented, reduced risk. Example: I identified the ambiguity early, brought the product owner, QA, and front-end developer together, clarified the expected behavior, documented the decision, and prevented inconsistent authorization logic from reaching production. Good communication prevention topics you can use. Depending on your experience, you can talk about clarifying authorization requirements, raising an integration blocker, clarifying timezone rules, preventing a risky deployment, discussing Kafka duplicate processing, aligning front-end and back-end contracts, correcting database deployment order, clarifying sprint scope, identifying missing regression testing, communicating an external API dependency, raising performance concerns, clarifying validation behavior, coordinating a production rollback plan, identifying missing audit requirements, clarifying data migration mappings. Final summary. Tell me about a time communication helped prevent a problem is an important interview question because strong software teams prevent issues through early, clear, and respectful communication. The best answer should include check what potential problem you noticed, why it mattered, who needed to know, how you communicated it, what questions you asked, what solution or mitigation you proposed, what decision was made, what problem was prevented. Good examples include check, preventing an authorization issue, check, avoiding an integration delay, check, preventing incorrect report calculations, check, avoiding a risky late deployment, check, preventing duplicate Kafka processing, check, avoiding API contract mismatch, check, preventing a database migration failure, check, avoiding unrealistic sprint scope. The strongest answers show proactive communication, risk awareness, collaboration, ownership, and prevention of real business or technical problems.